Hi, welcome to Lab 5. Here I'm going to make a very basic example of a two-dimensional collision. I've captured this video which shows a collision between a ball whose mass is 50 grams and a can whose mass is 200 grams. And I've set the coordinate system such that the origin is the point where the collision happens. I used tracker to extract the motion from this video and plotted two separate tables. Each contains the x and y position and the x and y velocity of an object. And I'm going to show in details how I use these data to make a computational model of this motion. First, let's take a look at the fundamental principle that I'm going to use. Newton's second law. Here are the two formulas that I'm going to use in Python to predict the motion. Here, using the changing momentum, we can determine whether the collision is elastic or inelastic, whether there is any energy dissipation by the surroundings or not. Now there's one final note before we go to Python to make the computer model. Here's the x-coordinate versus time graph. I'm going to cut this period into two intervals from here. So, for the ball, we notice that the speed of the ball looks constant in this interval. So, from Newton's second law, the net force here is 0, and that also applies for the can. And if we look at the second interval, we see that this is also true, at least for a short time after the collision. And this applies for the can as well. Now it's time for coding this and predict the motion. I've drawn a sphere to represent the ball, and a cylinder to represent the can, and two trials to represent the path or the trajectory of each of them. And I've inserted the position and velocity initial conditions that are directly from tracker. The mass of the ball is 50 grams and the mass of the can is 200 grams. And the momentum of the ball and the can are measured like this. T is the time where we choose to start our clock, and delta t should be small enough compared to the period of the motion. And if net is 0, and I think I've explained the reason, now I have two loops. The first one is before collision and the second one is after the collision. And the steps in the two loops are identical. The only difference here is the velocity after the first loop and in the beginning of the second loop. And these are the values I got from tracker. Now let's see the steps inside one loop, and that's exactly the steps in the other loop. First, I set the initial momentum of the ball. Then I use Newton's second law to update the velocity and the position of the ball. And so the final momentum of the ball after this time step. Then I calculate delta p from the value that I got from the first and fourth step. Then I set the final momentum to be the initial momentum for the next step. The same steps goes for the can. And then I use these two lines to update the graph or the trajectory of the ball and the can. The last thing here is checking whether there is any energy dissipation or not. So the program will calculate delta p total. And if the magnitude of delta p total is equal to 0, the program will print this sentence: the collision is elastic. And if it's not equal to 0, the program will print the collision is inelastic, and it will print the value of the energy dissipation, which is the value of delta p total.